Well, this video is for Math 111. In this video, I'm going to talk about Newton's law of cooling. I'll do an example from the textbook, number 8 on page 183. Let's see here. And then I'll also talk about the project. Part 1 of the project deals with Newton's law of cooling. Part 2 of the project deals with a similar application about the negative exponential. So first let's talk about Newton's law of cooling. So this is explained both in the textbook, let's see here, on page 178, and also on the front page of the project. The temperature at any given time is going to be the ambient temperature plus this constant times e to the minus kt, where k and c are constants that we have to find out. Okay? That t sub a is something that's normally given to you. There might be a problem where somebody makes up a problem where you have to find out the ambient temperature, but that's not true of the project or of problem 8 that I'm going to go over here. Problem 8, we've got a roasted turkey taken out of the oven when its temperature has reached 185 degrees, placed on a table in a room where the temperature is 75 degrees. Okay, so right away we know the ambient temperature is 75 degrees. Now the other piece of information that is in this description is that at t equals 0, we know that the turkey temperature is 185 degrees. So we can plug this information in, and what that's going to do is allow us to solve for that big C constant. Okay? So let's go ahead and do that. Let's see here. So the temperature, we know the temperature is 185 degrees. So let's plug that in. 185 equals 75 plus CE to the minus k times 0. So what's so important about this t equals 0 situation is that here you're going to have e to the 0 power, right? Whatever k is, 0 times k will be 0. E to the 0 power is 1. So we can just write 75 plus c. And then we can subtract 75 on both sides, and that'll tell us C is equal to 110. Okay? All right. So now we've got some more information about this. 110 e to the minus kt. All right. So that allowed us to find the value of C. And then, if the temperature of the turkey is 150 degrees after 30 minutes, let's see, so in this situation, we'll have T running in minutes. And then the temperature, capital T, is going to be 150 degrees. And then the question asks, what is its temperature after 45 minutes? So we'll answer that question in just a minute. But what we're going to do is we're going to take this information and we're going to use that to find the value of k. Okay, so now we plug this in. 150 is 75 plus 110 e to the minus k times 30 minutes. Okay, so 150, 75 plus 110 e to the minus 30k. So we want to get this k by itself. So let's get rid of these, the 75 and the 110 first. So we're going to subtract 75 on both sides. So that'll be 75 equals 110 e to the minus 30k. And then we have to divide on both sides by 110. So e to the minus 30k is 75 over 110. I believe that's going to be 15 over 22. It doesn't matter. You can leave it 75 over 110 if you want to, because in the end we're going to take the logarithm on both sides. Okay, and so let's go ahead and do that. I'm going to use the natural log because I've got an e here. That's going to make my calculations a little bit simpler than they would normally have been. So now what we're going to have here is we're going to have this ln 15 over 22, bring down the minus 30k in front, times ln e. And so this is what we talked about in class the other day. Ln e is equal to 1. Okay? We talked about why that is. It's because the base here is e. So e to the first power is e. So ln e is equal to 1. So 1 times negative 30k is still negative 30k. And so to finish this problem off, well, at least to find the value of k, we're going to divide on both sides by negative 30. And let's get a good approximation for the value of k here. ln 15 over 22, and then divide that by negative 30. And let's see here, 0.01277. 0.01277. So that's a pretty good approximation for k. And now, once we know that, let's see here. So, 0.01277. Okay, so now we've got a value for k, we've got a value for c, we've got a value for the ambient temperature. Now we can answer this question. If T is 45, then what's the temperature at that time? So I'm just going to calculate this directly on the calculator screen. I'll come around actually and show you as I'm doing it here. All right, so what we're going to do, and I'll write this on the board once I get done. What we're going to do is we're going to calculate 75 plus 110, and then the e is right there, e to the x. So you go second ln will give you e to the x, right? And then we want negative 0.01277, and then times the 45 minutes, because that's the value for T. And so that gives us about 137 degrees, 136.9. Okay. So what we're going to do here, right, is plug in the 45 times 45, and we get 136.9 degrees. Okay, so let's look at the project as compared to this problem. So in the project, we've got a cup of coffee that is brewed at a temperature of 205 degrees. So that's saying at T equals 0, the temperature is 205 degrees. So remember, that allows you to find the value of C. And the room, the ambient temperature in the room is 70 degrees, so that'll give you the T sub A. So right away, you've got the T sub A and the C value easy to solve for at least. 10 minutes later, the temperature of the coffee is 170 degrees. So once you plug in for T sub A and then you find C, take this piece of information, make the time 10 minutes, and this temperature over here 170, then you can solve for K, just like I did in problem number 8. Okay? So that'll give you the full equation, and that'll allow you to answer the questions. Figure out when the coffee cools off to 100 degrees. So you would set this equal to 100 and then solve for the time. And then I do ask you to make a graph for that as well, and to show that the intersection on the graph matches what you found algebraically. Okay, so part 2, like I said, is a little bit different. Again, this is about anesthesia, but it is a similar graph. It's still this negative exponential tail that looks something like this. Okay, So in this problem, what we're given is that after 1 hour, the concentration is 40 milligrams. And then after 3 hours, the concentration is 25 milligrams. Okay? So there's a couple of things that you can do here. This equation is a little bit simpler. You've got A, E to the minus KT, and that's because this is going down to 0, whereas in Newton's law of cooling, it's going down to the ambient temperature in the room. Okay, so there's 2 ways that you can use this information to find the values of K and A. Okay? One thing you can do is to plug in, 1 for T and then 40 for the Y value, and then plug in 3 for T and 25 for the Y value, and then you'll have a system of equations, and you can solve that pretty easily by substitution. The other thing that you can do is you can pretend that this is a different scenario that starts up at 40 and then after 2 hours goes down to 25. So you'll have to go back and solve for A if you do it this way. This allows you to find the value of K, though. You could do this to find the value of K and then go back to this to find out what the value of A is. Okay? So, as always, all of these helpful suggestions make a lot more sense the more that you've worked on the project and thought about it. And if you have any questions, while you're working through this, Ian is happy to talk to you in the math lab. I'm also available. You can talk to me, at the end of class, during my office hours, or whenever it may be. But please do talk to somebody if you get stuck. We're happy to help you. Thanks.